we talked about some general properties of triangles. Now we're going to talk about properties of specific types of triangles. The first one we're going to deal with is an isosceles triangle. So if I tell you that this is my isosceles triangle, can you remember which side would be the base? The problem is, most people when they hear the word base, they assume it's the one that's on the bottom. Okay, but we defined the base of an isosceles triangle as the non-congruent side. Well, it looks like these two sides would be the congruent ones. Since I'm told that's isosceles, that means it's going to have two congruent sides. That would make this my base side. It's important that you can identify which side is the base for the next theorem that we're going to work with. So we've got our base side, which also means we have some base angles. So the angles that touch the base, namely this angle here and this one here. Okay, those are our base angles. This other angle here is going to be the vertex angle. Okay, so the one that's not touching the base. Now, what our base angles theorem says is if two sides of a triangle are congruent, like we have in every isosceles triangle, then the angles opposite of them are congruent. So what it means is our base angles, okay, because our base angles are going to be the angles that are opposite these congruent sides, they're going to be congruent as well. Now, it turns out the converse of this statement is also going to be true. So the converse, if you remember, we're going to switch our if and then parts. Our hypothesis and our conclusion are going to get switched. So our converse is going to say if two angles of a triangle are congruent, then then the sides opposite of them are congruent. Okay, so that's what our converse is going to say, and that's also true. So it goes both ways. If we start with congruent sides, we're going to get congruent angles. If we start with two congruent angles in a triangle, we get congruent sides. So if we go from sides to angles, that's the base angles theorem. If we go from angles to sides, that's the base angles converse. Okay, we've got a couple corollaries here. So if we're dealing with this specific case where we have an equilateral triangle, okay, so I've got one here. Equilateral means I've got three congruent sides. Well, these two sides here are going to give me these angles congruent, and these two sides here would give me this angle congruent to this one. So in an equilateral triangle, I get equiangular. So if I know all three sides are congruent, I also know all three angles are congruent. Now, let's take a minute here and figure out how many degrees these angles would be. Because our triangle sum theorem tells us that we're going to have a total of 180 degrees. If this angle is x degrees, this and this would also have to be x. I've got 3x has to equal 180, so x is going to be 60. So every equilateral triangle has all 60-degree angles and all the sides are the same length. This is actually there's a special word for these shapes that have three congruent sides and three congruent angles, like this one does. That special word is regular. So this is a regular triangle. Okay, regular means all sides are congruent and all angles are congruent. So can you think of another shape that has all of its sides congruent and all of its angles congruent? Okay, how about a square? Square has 4 of the same sides, and all the angles are 90 degrees, so they're all the same. So a square is a regular quadrilateral. Quadrilateral is 4-sided shape. So um, this is just kind of a precursor to what we'll get into in a later chapter. I just wanted to introduce this word regular because eventually we'll be using that quite a bit. So a regular triangle is an equilateral triangle, which implies it has 3 congruent sides and 3 congruent angles. The other corollary is if we start with an equiangular, we get that it's equilateral because these 2 angles would give us these 2 sides. These 2 angles would give us these 2 sides. So let's look at some real basic problems we can do with this. If this is 10 degrees, okay, and I've got these 2 sides congruent, these congruent sides tell me that these sides are the same. So let's call them x again. And I know that x plus x, 2x, plus the 10 degrees that I have should equal the total degrees in the triangle. So I can use this to solve for what x is. So if I subtract the 10 over, I get 2x equals 170, which means x is going to be 85 degrees. So each of these angles would be 85 degrees. Now here I've got an equiangular triangle, which means it's also equilateral, or it's a regular triangle. So if this is 6 meters, all these other sides will also be 6 meters. Here's some more examples we can work through. So I'm going to leave these up. You just hit pause and try to find x and y for each shape. And then when you're ready, hit play again and make sure that you get the same answers that I do. So this first one, I've got these 2 congruent sides, which tells me that these 2 angles are the same. So x is going to be 35 degrees. Now to get y, I've got this side and this side congruent. So that means this angle is also y. And I could do it 2 ways. First, I could use the fact that I have a linear pair here to find out how many degrees this angle is. And then I would take 2y plus this, which would be 145, should equal 180 degrees. And I could solve that for y. Or, if you look at this picture a little bit differently, here's my triangle. This would be an exterior angle. So it should equal the sum of these. So I could just say 2y is going to equal 35 degrees, which is exactly what I'd get if I subtracted this 145 over. So it kind of saves me a step. So divide by 2, and I'm going to get y is 17.5 degrees. Now here, if I try to use my triangle sum theorem and say that 5x plus 75 plus 3y equals 180, I've got 2 variables, and I'm not going to be able to get anything from that. But if I use my base angles theorem, okay, these sides are congruent, so these angles are congruent. I can just say that those are equal. If I divide by 5, I'm going to know that x is 15 degrees. Now I know that this is 75 and this is also 75, so these angles down here take up 150 degrees of my 180, leaving this to account for the other 30 degrees. So y would have to be 10 degrees. The last example here, I've got an equilateral triangle inside here, okay, because it's got 3 congruent sides. So I know that all of these angles are 60. I'm hoping that'll help me out at some point. Now this and this, these 2 sides are congruent, so this also has to be 70 degrees. So that's 140, leaving x the other 40 degrees in this triangle. Now for y, I've got this side and this side congruent, so this is also y. And I could see that this would be an exterior angle here. Okay, and this angle is 130 degrees, and that should equal y plus y. So 2y should equal 130 degrees. So y is going to be 65. Now I could go about it a different way. You could take 180 and subtract these. Okay, you get 50 degrees here, and then say 2y plus 50 equals 180, and solve for y that way also. So this is how you're going to use your base angles theorem. It's also we learned about equilateral triangles so that we always know we have 60-degree angles in there and three congruent sides.